Hello guys, what is up and welcome back to another video. Today we're going to be talking about something in programming that is very useful. It is called a stack. Now a stack is a higher level data structure that is quite like a list but it has some different mechanics. It is more scientifically called a linear data structure, which means that every single item is it's stored in rows that you can visualize. And it does follow a particular order in which the operations to the stack is performed, right? So we can memorize this as LIFO, okay, which means last in, first out, and I'll explain what this means really quickly. But we can also remember a stack as FILO, which means first in, last out, right? So what this means is that, let's say you to like really feel this and to get to know this, let's say you have a stack of plates or the dishes that you need to wash, right? So when you're stacking those dishes, you take one dish, put it in your hand, and take the second dish and put it on top of that first dish. And you carry the whole pile of dishes to the sink, right? But when you begin washing your dishes, you usually take the first plate from the very top of the pile of dishes, not from the very bottom. So we can first talk about LIFO, last and first out. So the last plate that gets put into the pile is the first plate that's taken out, right? So let's say I'll use hashtags to represent each plate. So this is plate 1, plate 2, and right now this is the person collecting the plates, and it's going from bottom to top. But when you're washing them, right, you're clearing them out from top to bottom. So what happened there was that the last plate that came in was the first one that got to be washed, and the first plate that came in was the last one that got to be washed. Now here are a few main operations performed in the stack that is called push, okay, which means to add an item into the stack. There is pop, which is removing an item from the stack. There is kick top or return top, and that is to print the top element dash item of stack without removing it. And then finally, have the function is empty or just empty. And what that is that just returns bool whether if stack is full, if stack is empty or not. Okay, so now we have the 4 functions that we will implement into the stack. So now let's begin. First of all, I want to say that to decide this is empty function, we will use a system module called max size. And basically, if we import, right, so from sys import max size, and if we print max size, see it's this very big number, and this number is basically the largest int size that Python can handle. So you can go and search up max size sys Python. So moving right along, let's create the functions that we need for the stack. So first, of course, we need to create a stack, right? So we will do create, def create, and then we will have variable. We want a variable right now, and then we'll have stack equals an empty list. So this is the array list implementation, and then we return stack. Pretty simple. This is just creating the stack and then printing the stack. Okay. Next, we create the push function, stack item. This will basically help decide, help add an item into the stack, right? So push stack item, and then we just append the item into the into the stack, because right now our stack is a list. So then, just to let the user know that it's been successful, we just do print item and then concatenate that with pushed. Okay. Next, we will do the pop function. This function, again, it will remove an item from the stack. Because the pop, we need the is empty function. I forgot, so just name it is empty, because that's like the usual name, and then we can do return the length, right, of the stack equals 0. So this is the boolean. So like, if the length of the stack goes 0, then you return true, otherwise return false, right? So then here in the pop, we first need to take a look at if the stack is empty. If the stack is empty, then you can't pop, because there is nothing to pop, right? So if it is empty stack colon, then we return, right? And then the logic here is that if it is empty, then we return basically the minus version of max size. So return max, return max minus max size. Okay, so basically, if it's empty, then if the stack is empty, then we return minus max size, just so to let the reader know that it's empty. We can also do like a like quotes here saying empty, whatever. And we can return stack.pop. So this is okay. What is that? Okay, yeah, it's a type property. Pop. Okay. Basically, stack.pop will pop the item away from the stack. That is a inbuilt Python function, right? So the last one is going to be the return top function. Remember to print. It means to print the top element of the stack without actually removing it. So we can stack item colon. So here, we don't need the item here. So here what we do is that use if, right, and then again we need to take a look at if it's empty or not. If it is empty, then again we have nothing to return. So if it's empty, return minus max size. Okay. And then if it's not, well then return. And then what we need to do is that we need to first, because we're using a list, we can use indexes on that list. So we first index the list stack, right? Then we take the length of the list stack, because again we need to return the topmost item on the list, and we minus that with 1 because the length will always be larger than the index value by 1. So then we'll have a test program right here to make sure that everything works. Okay, so let's first have a stack. So we do create. There we go. So we have our stack created. Then we can first run a bunch of push functions. So stack, and then we could do maybe 15 push stack, 15 push stack. Let's check if this works or not. Oh, what does it say? Let's see here. Unsupported operand types for int and stir. So line 20 and line 35. Okay. So we oh, okay. Okay. It's pen item. So I think here we have to do stir item equals stir item, and then if we run that now. Okay, there we go, that works. It was just because the item was an integer, and then this is a string concatenation, and you can't apply a string to an int. So I got that one wrong. Okay. So the push works. So now let's do pop stack. Let's pop 16. What's this? List attribute. List object has no attribute pop. Let's check. Pop. Let's see. Okay. So let's just add a print function here. So without this print stack, so that does work. Wait, okay. I think it's, yeah, because I'm doing it inside. What if we go like that? Should that work? Oh, it needs a required. Oh, what's that line? Line 40 required argument pop stack item pop stack. Oh no. We don't need the item, I think. Yeah, we don't need the item because we're not adding anything new. We're just taking it out. So no, it does not pop. Is it not spelled correctly? Pop. Okay, where is it? Okay. Okay. So I guess if we pop stack, so if we just do print pop stack, does that work? We've popped it, I think, so we can just add popped, and then we can print stack. Okay, so that does work. So what I did is that I first of all got rid of the item here, and then for some reason my P here was a capital. I don't know why, but that just happened. So we don't need an item here because we're popping something, we're taking something out, and because it's first in last out or last in first out, as we see here, LIFO or FILO. We don't need to specify the item because the logic of stack already does it for us. So that's good. Now let's test is empty. So we can delete all that, and then we just print stack is empty. Okay, stack. Yeah, okay, we need stack. But okay, that's not good. Okay, yeah. No, no, no. We don't need the print. I think is empty. Yeah, and then we just need stack. Okay. Okay. It didn't return anything, which means that I guess it's yeah. I think it worked. Let me just double check. So to make it print is empty. Do I have to print this? Okay. I think I don't need actually this stack call. Okay. Yeah. Okay. So that works. As you can see, I've created the stack, but I don't have anything in it. I don't have any push items, push functions. So the stack is right now empty. And if we run that, it says it's true, it is empty. However, as soon as we push an item into the stack, so push stack, and then let's do just 14, it becomes false because something is in the stack. Now finally, let's check out return top stack. Name C is not defined. That's weird. Okay, we don't need to print then. Yeah. 14 push, return top stack is empty, negative max size. Yeah. Okay. So so here, as you can see, let's just really quickly add a lot of items here. So now we have 20 items. 4 items. Yeah, when that we get 40. Why? Because 40 was the last item pushed. As you can see, last in, first out. So this was last in, and then when we return the top, this is the first out. Now the stack can be used many purposes in Python, and the pros of a stack is that it's very easy to implement, and it is because memory, a lot of memory and time is saved because there's no loops and no pointers, and enumeration is evolved, so it's very easy to implement and it's very efficient. However, it's not. It is a static structure, meaning that when you run the program, it will not shrink or get larger depending on needs. So in Java, the Java array list is dynamic. It can shrink and expand depending on needs, but a stack is fixed or it is static. So thank you for watching today's video. Today's video was about how to implement a stack with Python using functions and using an array. Thank you for watching. I hope you learned something. If you enjoyed this video, please leave a like down below and subscribe. It'll mean a lot to me. And yeah, thank you.